Hi, I'm David Pearson from the University of California at Berkeley, where I teach in the language, literacy, and culture area. What I've learned about disciplinary literacy really relates to disciplinary literacy in science, because for the past almost a decade now, I've been working on a project with my science educator colleagues at Lawrence Hall of Science at UC Berkeley. And what we've been doing is trying to build this curriculum and validate it and test it experimentally, and it's called Seeds of Science, Roots of Reading. Get the organic metaphors in there. And so what we're trying to do is to figure out how to use reading, writing, and language to enhance the acquisition of knowledge and inquiry skill in science. And we've done it in grades. First we did grades 2 through 5, and then now we're right in the middle of doing 6 through 8. And we just got a grant, and we're going down. We're going to do K and 1 in the next round. But when we do it, our model is pretty straightforward. What we try to do is to figure out how we can cover the important science ideas and knowledge domains that have to be covered according to the science standards and now the next generation science standards. And then what we try to do is to embed comprehension, vocabulary, and writing activities into the science units. We try to balance hands-on inquiry-based science, what we call first-hand investigations, with reading about other people doing similar investigations, what we call second-hand investigations. So first-hand is when you do it yourself. Second-hand is when you read about somebody else doing it. And we try to create these synergies between the literacy and the science. For so many years, our friends in science have thought of literacy as the bad guy, because literacy stole time away from science. And furthermore, by making all of science instruction simply text-based and not experience-based, it gave kids the wrong impression of what it is that scientists do. Now, granted, scientists do a lot of reading, writing, and talking when they're doing their science, but they also do hands-on investigation. And so we're trying to build a program where we lead with the science ideas. What do we want kids to know and to be able to do in the area of science? And then we support the acquisition of that knowledge and those inquiry skills with the reading, writing, and language activities. Well, and at the middle school level, we're relying on a different kind of hands-on experience. It's so hard in certain kinds of areas to study things hands-on, up close and personal. So we're using a lot of simulations. So for example, when we're studying the digestive system and its interaction with other body systems, what happens is you get this simulation that's delivered on a tablet computer. And what happens is you can have different kinds of intakes, like you can eat foods that have different nutrient characteristics. You can change the amount of exercise that the person does. You can change, you can give the person a disease that slows down metabolism or something like that. And all of these things have an impact on the person's health. And what it does is it takes all the relevant variables that affect the interaction of the digestive system and the respiratory system and the like, and it shows what happens when you have a change in any one of these variables. And it's very effective. And if you think about it, it's a simulation where you couldn't really do a live hands-on kind of experiment, and the simulation really drives home the point. Now, the kids are also reading a lot about different body systems and how they interact and the like, but the hands-on, again, goes with the reading and the writing. And then at the end they have to come up, I know what they do. They have to design an energy bar that's going to maximize folks' capacity to engage in, some kind of activity with a high degree of endurance. Yeah, and they use all this knowledge that they've been accumulating from the reading and from the simulation to now write up their case for their energy bar. Now I want to invite you to explore an inquiry lesson in an earth and environmental science area that was designed for a group of 9th grade students. Students were asked to explore a river basin in their home state and creatively synthesize their research into a presentation directed toward their peers. For this lesson, the inquiry question is teacher-developed. Students will choose which river basin to study, and the compelling question that the teacher asks is this: how do humans influence water pollution in North Carolina's river basins?